All right, so let's talk about solving the second type of projectile motion problems. So this time we've got something that is typically launched off of some kind of cliff or edge. It's launched horizontally, and then the path downward is a projectile. Right, so the launch angle is 0. Since it's being launched horizontally, we don't have to worry about vector components for velocity. And your max height is the launch height. So again, looks like this. All right, your max height is occurring when time is 0. Your initial velocity is your horizontal. Initial for both horizontal and vertical. Well, initial vertical is 0. Sorry. Your max height happens at launch time. Yeah, that's pretty much it. Here's your horizontal distance, vertical distance, obviously. We can find your final velocity very easily. So again, you've got your range, horizontal, and your time, vertical displacement. Initial vertical is always going to be 0. Our final vertical we'll have to find. Acceleration is still negative 9.8, and our time is the same on both horizontal and vertical. We'll solve for time, finding our change in height, which will be negative, to determine the time to hit the ground. We don't have to find max height. And we can use the Pythagorean theorem in tangent to find our final velocity, right? Because what we'll solve for will be our final vertical, but then we have to find our final, like the other part of it. Yes, I'll show you in a minute. Okay, so a stunt car is being used in a movie scene. The stunt car will drive off a 74.7 meter high cliff with an initial horizontal speed of 55 kilometers per hour. Notice that's not in meters per second. We'll have to convert. To film the stunt, the director needs to know how long the car will be in free fall, and how far from the base of the cliff the stunt car will land. So we're looking for time, and we're looking for horizontal distance and final velocity. Okay, so let's look at this picture. Okay, so I'm going to do like I did yesterday and shrink. So we have horizontal and vertical. All right, so let's write down what we know so far. Okay, so 74.7 meters high, right? So it's falling down, so let's make that negative. Okay, we know acceleration is always negative 9.8 meters per second squared. And we know VIY for these type of problems is 0. So that gives us a lot. And we know our Vx is 55 kilometers per hour, but we have to convert it. So 1,000 meters is 1 kilometer, and 1 hour is 3,600 seconds. So then you get 55 over, divided by 1,000 times 3,600. I'm going to pause to do the math on my sad phone calculator. Y'all, I did it backwards. I'm sure you are wondering what I'm doing. To be fair, my internet's been out all night, and it's really late, and I need to go to bed. So 1 kilometer, 1,000 meters. I knew that didn't look right. So 55 times 1,000 divided by 3,600, 15.28 meters per second. Okay, so what is the easiest thing to solve for first? your answer should be time. So let's use the vertical information we have to find time. All right, so let's use d equals VIT plus 1/2 AT squared. So negative 74.7 equals 0T plus 1/2 times negative 9.8 T squared. I gotta make room. So that goes away. So divide by the negative 4.9. Is 15.24. That's me rounding it. I don't want to round at that point, but I'm just leaving it in my calculator and then taking the square root. So then T is 3.9 seconds. Okay, again, I rounded it to write it down, but I left it in the calculator and took the square root of the whole big long decimal, so I got a more exact time. Okay, so if it's 3.9 seconds vertically, it's 3.9 seconds horizontally. So now we can use, let's not use red. Speed equals distance over time. So multiply both sides by your 3.9 to get it out of the denominator. So 15.28 times 3.9 gives us a horizontal distance of 59.59. Okay, so now all we have to do is find the final velocity. So let me do some, nope, not how I want to shrink. Hold on. I'm going to pause and make more room. Yeah, I don't know what's happening, but either way, hopefully you guys can see enough of that if you still need it. So let's find final velocity. So I'm going to use VF equals VI plus AT. So we're just going to do negative 9.8 times 3.9. So our final vertical velocity is 38.22. So let's now find our final overall velocity, not just vertical. Okay, so to find our final overall velocity, your initial is going to stay the same or your initial vertical, so that's our 15.27. Our final vertical was 38.26. So then you just use Pythagorean theorem to find it. So the math is all right there. I'm not going to work it out again. You guys can read that. So square the 15.27, square those, add them together, take the square root. So your overall final velocity of this component here is 41.2 meters per second. All right, there should be a type 2 practice problem that you guys can try. Again, email or text me if you have questions, and let me know how I can help.